Hey folks, this is the second video in section 4.2 that deals with synthetic division. We're just going to do an example here. Notice first of all that my divisor has a leading coefficient that is 1 and it is also linear. Remember, these are the two requirements to using synthetic division. The first thing that we're going to do, following here the how-to over on the right there in yellow, just grab all of your coefficients and make a list of them. Make sure if you have any missing coefficients that you put a 0 as a placeholder in for it. The second thing that we're going to do is whatever x equals has to go in the box. So if you will take this linear divisor and pretend it's a small equation and solve for x, you'll get that x is equal to -2. So x equals -2 is what's going to go in the box. The next thing we're going to do is bring our leading coefficient down. There's no math involved in that. Just simply copy that leading coefficient. Then take your leading coefficient and multiply the box. So this is going to give you a -10. It's going to go in the spot above the equation bar. And then lastly, you're going to add those two together. So when you add those two together, you're going to get a -16 and start the process over again. So take that number, multiply the box, you'll get 32. Add these two together and you're going to get a 4. Multiply the box, you'll get a -8. Add those two together, you'll get 0. Put a bar in between the last number and the rest of them. This separates the remainder from the quotient. So our quotient here is going to be 5x squared minus 16x plus 4. The remainder is 0. For the record, this last number here before the bar is always our constant, and from there we're going to walk our variables with their powers up. So this guy gets the x to the first, this one gets the x to the second, the one in front of that, if I had one, would be x to the third, etc. Now go down a little bit in your notes to the remainder theorem. If I want to find P of k, you'll even notice down in example 4, if you wanted to find P of k when k is 2, before today we would have just plugged and chugged. But there's an easier way, and we can use synthetic division, which is now called synthetic substitution, to do this. So if I want to find P of k, all I have to do is find the remainder when k is in the box and use synthetic division on that.